Hello, welcome to video number 71 called Probability Models. It's just me today. Mr. Lewis is off doing whatever Mr. Lewis is doing. He'll be back in the next video. I'm going to take this opportunity to kind of go over what we're doing in class again about probability models, expected value, variance, and standard deviation. Okay, so here's our first example, and actually this is the toughest one because for this one we're not going to use our calculator. First, it says consider the probability model shown below. So here we have a random variable x. It can take on the values 0, 1, or 2 with these probabilities. So the probability that x is 0 is 0.2, probability it's 1 is 0.4, probability is 2 is 0.4. So we see that this random variable is twice as likely to be a 1 as a 0 and twice as likely to be a 2 as a 0. And getting a 1 and 2 are equally likely. All right, so the first one's actually kind of done for us. It says use simulation to find some sample values. So I actually did this on my calculator, kind of like we did in a simulation chapter. And here's some sample values. Okay, so we can only get 0, 1s, or 2s because that's the only values our random variable can take on. And if we did this in the long run many times, we should see that 40% of them are 1s, 40% of them are 2s, and 20% are 0s if we did it a lot. Okay, now, this is what we're doing. We want to calculate the expected value for x. So if we did this many, many, many times, what would we get on average? That's what we want to find. Then, we want to find the variance and standard deviation for x. Again, these are theoretical values. If I did it many times, what would be the variance and the standard deviation of the data? Okay, so we could do a simulation and get experimental values, or we can do some theoretical calculations. Okay, so here we go. Let's do the theoretical calculations. Right, my pen's working. So it says find the expected value for x. Okay, well, we're going to use the formula over here. One symbol is mu, because this is a symbol for the mean when it comes from a probability model, kind of like the normal curve. And another symbol is E of x. I saw this all the time in engineering school, expected value of x. And this is the actual formula for it. When we multiply the data values by their probabilities, actually the values of the random variable times their probabilities. So here we go, mu, which is another symbol for the expected value of x, the theoretical average, is the sum of x times p of x. So in this case, we'd have 0. 0 times 0.2 plus the next value, 1 times 0.4 plus 2 times 0.4. And if we did this, we would get 1.2. So on average, in the long run, the average value for this variable, random variable, is going to be 1.2. All right, now, expected values, no problem. The variance is the tough one, and we take the square root of it to get the standard deviation. So sigma squared, we've seen the symbol sigma before. Sigma we use with the normal curve for standard deviation. And again, that's a symbol when it comes from a probability model. And or sometimes we call it SD of x. So if we square the standard deviation, we get the variance. That's how they're related. So that's why this is called sigma squared. So let's find the variance first. Sigma squared, which is the variance of x, is, well, what we got to do is take each value and subtract the mean and square it. So the first value is 0. We're going to subtract the mean and square it times the probability of getting a 0, 0.2. Plus, we're going to do the next value. The next value is 1 minus the mean squared times the probability of getting a 1, which is 0.4. Then we're on the third value. So it's going to be 2, the third value, minus the mean squared times the probability. Okay, you gotta give me a minute here to do this. So this is kind of a complicated calculation, and we're not going to do it too often anymore. 0 minus 1.2 squared. And unfortunately, there's a lot of room for mistake when doing this. It's easy to type in something wrong. Okay, I got just the last part to do. When I do this, I get 0.56. So hopefully I did everything correct. So sigma squared, which is the variance, is 0.56. So the standard deviation, which is just sigma, is the square root of that. Okay, let me take the square root of that. And I get 748. So 0.748. Okay, so we have what our variable is going to be on average, and this is the standard deviation of the results. It's a measure of center and spread. Okay, so these are theoretical calculations of the average and the standard deviation of what we get if we did this many times. Okay, I spent a long time on this example. The next ones are going to go quickly because we're going to use our calculator from here on out. So here's a probability model. We're going to use our TI-84 to find the expected value, variance, and standard deviation. Now it's a little bit different if you have an updated calculator with a little updated software or the old one. This program I was using to generate these screenshots has the old one. So here's the probability model, and you have to enter the values of the random variable into list 1. And in list 2, you put their probabilities. Okay. Then you go to calc, one variable stats, which we use at the beginning of the year. And if you have a newer calculator, you put in the list L1, and the frequency list is L2. So if you have a newer one under frequency, you put L2. If you have the older version, like what's shown here, you have to put L1 comma L2. When you give one variable stats to list, it understands that it's a probability model. So either way you do it, with the old way or the new way, we get this screen here. Now, the first number here, X bar, it's kind of the wrong symbol for it. That's the expected value. So for this probability model, on average, the value is going to be 280 in the long run. Down here, we have the standard deviation, sigma. Okay, and so that's great, but we're missing the variance. The calculator doesn't tell us the variance. So let me write the results here. Mu, which is the expected value, is 280. I'm going to skip a little bit. Sigma, which is the standard deviation, is equal to 87.2 approximately. Now, since they asked for the variance, we have to square the standard deviation. So if we have the variance, we take the square root. If we have the standard deviation, we square it. So in this case, 87.2 squared is 7,003.84. 7,003. Wow, we have 7,603.84. Okay, so the variance is what you get when you square the standard deviation, or the other way around, the standard deviation is the square root of the variance. Okay, so we have to know the relationship between those two. All right, slowly but surely getting easier. Here's another example. It says the probability model below describes the number of repair calls that an appliance repair shop may receive during an hour. So there's a 10% chance they'll get no calls, and we see a 30% chance they'll get one, etc. How many calls should the shop expect per hour? That's the expected value. And what's the standard deviation? This is going to be lightning fast. So all I did is enter the probability model into my calculator, and I get exactly what they're asking for. That's the expected value right there. So the answer to A, 1.7 calls, not hours, calls. That's on average. Okay, what's the standard deviation? Measure of spread about that? Well, the answer to B is right there. Standard deviation is 0.9 calls, so 0.9 calls. That's it. So using our calculator, we can find these values very quickly. All right, time for the last example. This is a word problem. And usually the hardest part is actually coming up with a probability model. It says an insurance policy costs $100 and will pay policyholders $10,000 if they suffer a major injury, or $3,000 if they suffer a minor injury, resulting in lost time from work. So the company pays out $10,000 for major injuries, $3,000 for minor. It says the company estimates that each year, 1 in every 2,000 policyholders may have a major injury and 1 in 500 a minor injury. I'm having trouble talking. So, wow, what a mouthful. But if we come up with a probability model, this will all come together. So here, we're interested in the profit, how much the company makes. So the first case is that someone pays $100 and they don't get injured. Okay, so that's probably most of the people. They buy the insurance, but they never use it, and so the company receives $100 from them. The next case is if the company, if someone has a major injury, the company collected $100, but they have to pay out $10,000. This is very expensive for them. So in this case, the company would lose $9,900. Okay, in the case of a minor injury, they have to pay out $3,000. So they collected $100 from the person, but after paying out $3,000, this would be negative $2,900. Okay, so we have the possible values for the random variable. Now we have to figure out their probabilities, and that's what this information was about. 1 out of every 2,000 policyholders will have a major injury. That was here. 1 out of 2,000. Okay. And 1 out of 500, a minor injury. It's 5. If I did the math right, that would be altogether, that'd be 5 2,000. So that leaves 1995 over 2,000. How did I get that? I subtracted those from 1. Okay, so remember we get 1 probability from free because we can subtract the others from 1. Wow, that's the hard work, but that's the probability model. Now, everything's very easy. So we want to know, on average, what's their expected profit? So if they have a lot of major injuries, it's going to be in the negative. But let's see how it works out. So mu, which is the expected value of x, equals. Give me a second, I'm going to put it in my calculator. So in L1, I'm putting 100, negative 9,990, then negative 2,900. Okay, actually 9,900 for the second one. Right, I got it right in the calculator here. Okay, and then the probabilities. 1995 divided by 2,000. There's about 99.75%. Most people don't have an injury. The next one, 1 divided by 2,000. And the last one, 1 divided by 500. Okay, stat, calc, 1 variable stats. Okay, I entered it and came up with these values. Now I just have to read it off. On average, it turns out that they make $89 profit per person. Okay, so that's not bad. So even though sometimes we have to pay out the big bucks for a major injury or a minor injury, the average they're going to make in the long run is $89 per person. Otherwise, they wouldn't stay in business. C, what's the standard deviation? That's easy. I can just read it from the calculator. Sigma is 260.5. So we see there's a good amount of variation around the average. Okay, so remember that's a description of spread. All right, that was a lot, but hopefully we're starting to get feel better about this. These are theoretical values we're calculating that we would observe in the long run if we actually did the experiment. All right, it's your turn. Time for a word problem. It says a consumer organization inspecting new cars found that many had appearance defects, like they had dents, scratches, paint chips, etc. in the car. While none had more than 3 of these defects, 7% had 3, 11% had 2, and 21% had 1 defect. So here in the corner we have a picture of a hail damaged car. You can see that the hood is totally messed up. All right, what percent of cars had no defects? I added that question because it'd be easy to forget about that possibility. The possible number of defects are actually 0, 1, 2, or 3. Okay, write a probability model for the number of defects. It's actually all here, and you'll need your answer to part A too, but this is not going to be a hard one to come up with. Then C, use your calculator to find the expected value, the variance, and the standard deviation for the number of defects. All right, good luck with all that. See you in class.